Welcome to our class for today. This is Class Online School. I'm taking you basic science, and we are going to look at thermal energy, then heat flow. These are the two things we want to talk about today. We are going to describe what a thermal energy is, and then we are going to see how heat flow. What are the processes? Okay, so let's look at what thermal energy is. What is thermal energy? We're going to try to explain it. Sometimes we call it heat energy because it has to do with increase in temperature, higher temperature. So what is thermal energy? The thermal energy that comes from the temperature of the heat substance. Thermal energy, sometimes called heat energy, is the energy that comes from the temperature of the heated substance. This happens as a result in rise in temperature. Why? It's because atoms and molecules it causes atoms and molecules to move faster and collide with each other. Now, in simple terms, thermal energy has to do with rise in temperature. Rise in temperature. When temperature is raised, it becomes heated up. Now, let me use this illustration here. I have a kettle that has water on it. I have a stove that has fire on it. If I set fire on this kettle, it gets heated up. Now the boiling water here has thermal energy and kinetic energy. Thermal energy and kinetic energy. Why it possesses kinetic energy is because there is movement of the bubbles. Alright, and the thermal energy has to do with the heat that comes from it. That is thermal energy. Now let's go further to still explain what thermal energy is. Now, we look at it, we can equally say that thermal energy comes from a substance. These molecules and atoms are vibrating faster due to a rise in temperature. So that means that thermal energy can only occur when there is a rise in temperature. If the temperature is heated or high, we can say that it has thermal energy. Now let's say, for example, when this is a bowl, a glass of water, this is cold and this is hot. As cold particles heat, they contain more energy and so vibrate and separate. At this point, they coagulate, they bound together. But the moment heat is introduced into it, it becomes hot. These particles now separate because there is vibration. Have you put a pot in the fire? It starts bubbling and it starts heating up and it starts vibrating because of the boiling. So at this point, it vibrates and it separates. And once it separates, it will no longer band together like this. It will separate and will start bubbling. Now let's take, for example, your hot water. The moment you put it in the fire, at that point it's heating up gradually. Okay, and the moment it starts boiling, it starts bubbling from the bottom of the pot and will start moving. You see, it is no longer banded together. Right now there is vibration and there is separation, and then it will no longer be this way but this way. So in a nutshell, what did we see? We've seen that thermal energy can equally be said to be heat energy. That means that heat have to be introduced into a molecule for it to possess thermal energy. And so rise in temperature brings about thermal energy. If there is no rise in temperature, we can't say that we'll have thermal energy. So from the description, we see that it is the energy that comes from the temperature of the heated substance. You see it? An energy that comes as a result of heating a substance, a molecule. And so when it gets heated up, what happens is that it will move faster and they will collide with each other. And so at boiling point, when it is hot, it will separate because of the vibration that happens. And the moment it separates, the molecules are no longer bounded together. So if you look at this glass of water, it's bounded together because it is cold. But when you look at this, it is hot. It has separated. The vibration, it has separated. Okay? So this kind of energy is associated with rise in temperature. So anytime you hear the word thermal energy, know that they are referring to heat energy. So you can say heat energy, you can say thermal energy. This happens as a result of increase in temperature, rise in temperature. That's why we use the boiling kettle to illustrate this. Now let's look at the second objective. We've described the first objective. The second objective is heat flow. How does heat flow? We are going to look at how heat flows in three ways. Okay? We will look at radiation, conduction, and convection. That's the point we're going to look at now. Now let's look at heat flow. Heat flow has to do with a process where energy flows from a hot area to a cold area. A process where heat flows from a hot area to a cold area. Now we have three types of energy heat flow. We have three types of heat flow. We have conduction, convection, and radiation. Now let's look at them one after the other. What does it mean to say that heat flows in conduction? Conduction, because the movement of heat from one point to another, this is through a solid metal without obvious movement. Now let's take for example what I have on board. This is a metal rod. This long thing I draw here, you can call it a metal rod. And so I hold out a metal rod. This is a hand. Don't mind my caricature diagram. This is the hand of the person holding this metal rod. And now I hold out a metal rod, and these are candles. These you see here are candles. These you see here are candles. And I place 3 candles on top of this metal rod. Now, let's see how heat will flow from this metal rod to this candle, which will fall easily. Which one do you think will fall first? Now, I have another candle that I have light fire on. Now, the moment this candle heats up this metal rod, what will happen? Please do that experiment and record it. Hold out a metal, light candle lights underneath it, put 3 candles on top of it. Now when you light that, put this candle underneath it. As this candle, okay, transfer heat, there is a flow of heat from the candle to this rod. You will notice that the first candle to fall off the rod is going to be the first one. Why? Because the heat transfer gets so hot with this first candle. That's how the heat will be moving gradually. The first time you won't feel it in your hand, it will be here, and this candle will fall off. Next, the second one will fall off. Next, the third one will fall off. As the heat continues to heat on this metal rod, the heat will transfer until you get to where your hand is and you are not able to hold it. This is an experiment we can use to explain conduction of flow of heat energy, because one, metal is involved. This, a solid metal is involved, which is the rod, and the rod becomes the contact which flows the heat to the metal. And the more the heat stays hot, the more it moves from the edge of the rod. It goes further and further and further until the metal become hot in itself. Until the metal become hot in itself. You do not move this fire this way, but because it's heating up here, the metal is gradually heating up until it gets to the base point, or the edge, or the whole of the metal. In this instance, we've said that conduction of, or the flow of energy that have happened here has to do with conduction of heat flow. So that is for conduction of heat flow. One, I said the movement of heat from one point, which is this point, to another, is moving to another. This is through a solid metal or material without obvious movement. I'm not moving this fire through, but it's here and it's heating it up. No obvious movement, but it is heating from point A to point B to point C to point D until it gets to its final destination. That conduction of heat flow. Then we go to convection of heat flow. It is the movement of fluid molecules from higher temperature regions to lower temperature region. Now let's have two let's say this is a container containing cold water, and this is a container containing hot water. This is cold water, this is hot water. At this instant, conversion happens with fluid. Unlike conduction, it happens with metal, solid metals. But in conversion, it happens with fluid. So if I come here, and this is let's say this is my pot. This is water that I put on the pot, and here this is my stove that is emanating heat to it. What will happen to the fluid inside here? The moment the fire heats up the water in here, the fire here, the heat here, introduce a higher temperature to the water, which is the fluid. And what happens? It starts bubbling little by little beneath. The moment it starts bubbling, before you know, it starts boiling. The temperature have risen. And so the moment the temperature have risen, if I want to flow out, if I want to draw a flow, I can bring a pot again that have cold water. And the moment I transfer some cold water to this hot water and some hot water to this pot, you see that the temperature of water, if this is 100 degrees Celsius and this is 5 degrees Celsius, at the end of the day, if this is cold water and this is hot, this is cold. Okay, if this is 5 degrees Celsius and this is 100 degrees Celsius, if I introduce this hot water to this cold water and mix them up, both will have the same temperature. It will take maybe 40 degrees Celsius and 40 degrees Celsius. This is where we said they are in equilibrium, because I have flowed both water together. They've matched their temperature rate. The water is no longer too hot or too cold. I have mixed hot and cold water together. Now they have an equilibrium temperature, which might be 40 degrees Celsius, 40 degrees Celsius, instead of the 100 degrees Celsius and the 5 degrees Celsius that I have initially. So at this point, I will have an equilibrium in the flow of heat. This is convection. Convection happens with fluid and fluid molecules. So it will be heated up. You will introduce heat to it. Once it heats the source, which is the metal, the pan, or the pot, it will heat the liquid inside. The liquid will get heated up. It will start forming a bubble. The bubble will start going to up. You know, the hotness will start from the bottom and gradually it will bubble to the top. So once the gun is heating up, it gradually moves upward and it bubbles upward. So this is convection in heat flow. Now let's take the last one, radiation. Radiation happens with sun heat. You stand in the sun. Initially, when you will stand in the sun, you won't feel the heat. But the moment you go to the sun, you start feeling the heat. Before you enter the sun, you are not feeling the heat. But the moment you enter the sun, the heat of the sun start radiating through your skin. You start feeling the heat. Okay? This has no medium. It happens in vacuum. So, if it happens like this, we say that radiation have taken place. Okay, so the sun transfer its heat to our skin via a vacuum. That is how it works. The sun emanates this heat through electromagnetic waves. This heat gets to us. Okay, so these waves carry away the energy from emanating body. Radiation takes place through a vacuum or a transparent medium, which can be either solid or liquid. Thermal radiation is a result of the random motion of molecules in matter. So in radiation, it can happen via metallic substance. It can happen through solid or liquid. Through solid or liquid, and it gets its heat via electromagnetic waves. Now let me illustrate this with this. It's a pot. Okay, this is my source of power. This is a pot. If this is a pot, this is the fire emanating from it. The pot is the conduction, which is the metal. Then the heat, which hits the molecules, which is the convection. And then if you place your hand via the fire, you will have a radiation that will touch you. This is the radiation. So you can use this to explain the three of them. It can be via conduction, convection, or radiation. So in a pot of heat put in the fire, the pot, which is the metal, will serve as the conduction. The liquid, which is bubbling and boiling, is the conversion. And then the heat that is touching you, if you place your hands on it, become the radiation. So these are ways in which energy flow happens via conduction, convection, and radiation. So we've been able to see the two objectives. We've described what thermal energy is and how heat flows in the three processes. This will be it in our basic science class for today. We will have met our objectives for today. And so go through the class again so you can understand what we've taught you. Thank you for joining us. Subscribe if you're not subscribed to the channel. Okay? Watch other of our basic science class. This is basic science for Jss2. We are done with your Jss1. So follow along. Follow along as we take you from Jss1. If you follow sequentially, you will be able to understand it. Thank you for joining us. I'll see you in the next. Ask your question if you have any below the comment box.